All right. Last cycle of this semester. Now keep in mind that there's no summative 2B. If you're looking at the agenda, there's no cycle 2B summative. It is wrapped up into the cumulative exam, which is over everything. And don't be too scared. Every summative that you've taken so far has questions from the previous summative on it. So you've been practicing all along the basic skills for everything. The cumulative exam will just be a little bit longer than a normal summative. 2.10, verifying solutions. You guys, this will be so easy for you. I hope that you just fly through this. Maybe you don't even need to watch the video past the first one. So, if you are a chemistry lover, this question is right up your alley, and you should have no problem with it. So, chemical equations, like you see here, are similar to algebraic equations in many ways. But instead of solving, we need to balance. So what's on the left needs to balance what's on the right. The process of balancing a chemical equation involves finding coefficients so that the equation has the same number of atoms in each element on both sides of the equation. And if you are totally lost on what I just said, that's okay. Think of H2, see how there's that little sub 2? Think of that kind of as an exponent, and then the 2 in front is just a coefficient. So it's kind of I like to think of it as an upside down equation. Instead of exponents, we have these sub numbers. So let's explore a chemical equation that's balanced to understand the notion and the process. So what's on the left is equal to what's on the right. It's just written differently. Instead of 2x plus 4, we have maybe 2 plus 2x plus 2. They're both the same once I simplify and rearrange. They're just rearranged a little bit differently. So in this balanced chemical equation, there's 2 different molecules on each side, Ra and H2O. I'm not sure what Ra is. Does it tell us anywhere? I don't know. Maybe it'll tell us later. I know H2O is water. And then we have Ra and then OH2 and H2 on the right. Again, I have no idea what those are. That are comparable in terms, or comparable to the terms in an algebraic equation. The subscript on an element tells how many atoms of the element are in that compound. If there's no subscript written, just like exponents, there's just this implied 1. So you have x. Well, it's implied that the exponent is 1. We just don't need to write it. Coefficients are multiplied by subscripts to give the total number of atoms of each element in a particular molecule or compound. For example, if there's 2 hydrogen and 1 oxygen in H2O, the coefficient of the 2 makes 4 hydrogen and 2 oxygen atoms. Okay, so let's get started. So on the left-hand side, for Ra, there's 1. And on the right-hand side, there's 1. H, on the left-hand side, there's 2 H2, so I'm going to multiply those together. So I actually have 4 on the left-hand side. And then on the right, I would distribute the 2, and I have H2. So there's H2 plus H2, that's 4. And then for O, oxygen, 2 H2O, so there's 2 O's. And then over here, I would need to distribute that 2 to the O, and I get 2 on the right as well. So it's balanced. So we need to confirm the following chemical equations are balanced by showing that each element is the same count on both sides. So left and the right. So I'm going to distribute this 2 to the H2 and to the O2. I'll distribute the 2 to the H2 and the O1. And then the O2 I don't do anything for. So on the left-hand side, there are 4 H's when I distribute. And on the right side, when I distribute, I guess I did left side next, 4 O's. 2 times 2 is 4. And then on the right side, when I distribute the 2 to the H2, I have 4. And then distribute the 2 to the O and then add it on to the other 2. I also have 4. Same thing for part B. I'm going to distribute all of the coefficients to all of the subscripts, just like I would an exponent. So looking at the left-hand side, n, if I distribute the 2 times 2 is 4, plus 2 is 6. H, I'm going to distribute the 2, and I get 8. There's nothing in the second part, so just 8. And then O, it looks like I only have 4. And then on the right-hand side, I'll distribute the 3 to the N2, and that's 6. Nothing else. And then distribute the 4 to the H2, that's 8. And 4 to the O, that's 4 as well. So yes, this is balanced, even though it's written differently on both sides. And then for part C, I'm going to do the same thing. I'll distribute the 2 to everything. I'll distribute the 3 just to the CA, and then the 2 I'm going to distribute backwards. So that's a little bit different, something new there. And then I'll distribute the 2 there backwards and distribute the 6 as well. So if I count everything on the left-hand side, H, there's going to be 2 times 3 is 6. And then, I need to distribute that 3, this guy. I got to distribute it there and to there. So it's a lot going on. Okay. So I have 2 times 3 is 6. 3 times 1 is 3, times 2 is also 6. So that gives me a total of 12. And then for P, it looks like I just distribute the 2, so I've got 2. O, I have 2 times 4 is 8. And then 3 times 1 is 3, times 2 is 6. So 8 plus 6, that's 14. And then for CA, it looks like I just have the 3. Okay, so then moving on to the right-hand side, I'm going to distribute H. 6 times 2 is 12. P, I distribute the 2, so I just have 2. For O, I distribute the 2 to the 4, so that's 8. Distribute the 6 to the 1, that's 6, so 14 as well. And CA, I don't have to do anything for that one, it's just 3. So that one was pretty in-depth. I don't think you'll see anything more complicated than that one. Okay, so then the next part, super, super basic and elementary, I think. Solution of an equation is a number that results in a true statement when it's substituted in for the variable in the equation. So for example, I'm not even going to read through the example. These are way too easy. I'm not reading through the example. Read it through on your own time. Pause the video if you need to. Okay, so 2A. I'm going to plug in 3 for x. Is that a solution? I need to verify yes or no. So I'm going to plug in 3 for x. And I don't know if it's going to equal. That's why I wrote a little question mark over the equal sign. So then I'll just evaluate both sides. It showed literally all of my work just in case. And then -7, in fact, equals -7. So yes, that is a true statement. For part B, same deal. I'm going to plug in 2 for x, and then I'm going to evaluate. I don't know if they're equal yet. I can't do that math quite in my head super fast. So I'm going to write a question mark there. If you want to see like all of my steps, go ahead, follow through. And 10 does in fact equal 10. Yes, it is a solution. Part C. Plug in 5 for x. This one we have 5 in 2 different places. So I'll plug in 5 for x and then verify if it's a solution. So I'm going to evaluate both sides of the equal sign. And yes, 3 does equal 3. You're going to do the same thing for D and E. I'm not actually going to go through them with you because I think you should be able to do them on your own.